All right, so guys, what I'm doing here, this is Rules of Exponents. This is kind of like a review. So just so that y'all have an understanding, this is more of a review. I want to do some of this stuff here because I want us to get an understanding of some of the rules of exponents, and I think doing this is going to help us in some of the sections in Chapter 4. So first thing we're looking at is the expression a to the power 1 over n. And it says if n is an even positive integer and a is positive, then a to the power 1 over n is a positive real number whose nth power is a. And then it says if n is odd, an odd positive integer, and a is any non-zero real number, then a to the power 1 over n is either the positive or negative real number whose nth power is a. Okay, so let's see if we can figure out what does all that stuff mean. Okay, so I'm going to take a look. I'm going to pick some of these problems here, and the first one says 36 to the power 1/2. What this means is I'm looking for the square root of 36. Now remember, the square root means we're looking for pairs. So what number do we have a pair of? We have a pair of 6s, so 36 to the power 1/2 is the number 6, okay? Let's do the next one here. So I'm going to do a couple of these here so we get an understanding of how these work, okay? So I'm going to take a look at, say, these three, and I'll come back and do probably another one. But I want you to look at these because they have negatives on them, okay? So when I look at part B, it is negative 100 to the power 1/2. Now, the one thing I want to mention is that my exponent only goes to the number that's right in front, okay? Excuse me. So this means that I'm looking at the negative of the square root of 100. Well, the square root of 100 is 10. Okay, now for part C, I have the negative, and then in parentheses, 225 to the power 1/2. So again, the power 1/2 is only going to the number that's right in front of it. Okay, and I'll explain the difference between part C and part G in a minute. So again, this one means the square root of 225. There's a negative here. I'm going to bring the negative along. The square root of 225 is 15. Now, when I look at G, G is negative 27, and that's on the inside of the parentheses. And this is being raised to the 1/3 power. So this means I'm taking the cubic root of negative 27. Excuse me, I'm sorry. This one here was the square root, same as this one here, okay? Because that was my denominator. So I want to make sure that we have an understanding of what the cubic root means. If the square root means we're getting pairs, like a pair of 6s or 2 10s, right? Or, excuse me, 2 15s. The cubic root means I'm looking for sets of 3. So, well, I know that 3 and 9 give me 27, but I want you to notice that this is a negative 27, so I got to make that a negative 3. And then I'm going to break down this 9 into 3 and 3. The only thing is, all the numbers have to be the same. And if you notice, excuse me, if you notice this number here, there's a negative, and these here don't have it. But we could do this, still get a positive 9, and now all these three numbers are exactly the same. So the cubic root of negative 27 is a negative 3. Okay. So let's see. Let's try another one. Oh, I don't know. Let's take 625 to the power 1/4. So 625 to the power 1/4 means I'm taking the 4th root of 625. So, excuse me, if you can guess it now, we're looking for sets of 4. 4 of the same number, okay? So I can divide this by 5. That gives me 125. I can divide this by 5. That gives me 25. Let me scooch down a little bit. And then I can break these down each into 5s. So I'm taking sets of 4. So I have 4 of what number? 5. Okay. All right. So let me kind of scooch down here to some of the other ones, and we'll kind of get an idea of what's going on. All right, so the next part here says the expression a to the power m over n. So it says let m be any integer and n any positive integer, a be any real number for which a to the power 1 over n is a real number. We have this expression here, so this is how they're writing it. I want to point out that there's a couple, so what does this mean here? This means we're going to take the nth root of a, and then we're going to raise it to the power of m. So let's take a look at some of these problems here. If I look at the first one, look at my denominator. My denominator is 3. The denominator tells me what root I'm taking. So we're going to take the cubic root of 125, and then we're going to square it. So let's do this part first. Remember, I'm looking for sets of 3. So this is 5 and 25. This is 5 and 5. So the set of 3 that we have 3 5s. So this piece right here simplifies to the number 5. Now it's being squared. 5 squared is 25. Okay? Let's take a look at the next one here. So 32 to the power 7 over 5. This means I'm taking the 5th root of 32, and then I'm going to raise it to the power of 7. So let's break this down. 32, when I think of 32, a lot of times I tend to think of 4 and 8. And I know 4 is 2 and 2, and I know 8 is 2 and 4, but this 4 I can break up into 2 and 2 again. So I'm going to start circling. How many 2's do we have? We have 5 of them. So now this is saying, let's find 5 to the 7th. I'm going to take my calculator, let me turn it on. Okay, clear it out. And what is 5 to the power of 7? Wow, 78,125. Oh, I'm sorry, I put 5, it was 2, wasn't it? Oops. I knew something didn't seem right there. This should not have been a 5, this should have been a 2. So we went, oops. So we want 2, there we go, 2 to the power of 7. Sorry about that, guys. 2 to the power of 7. 128, there we go. That seems better. Okay. Pardon me. Okay, so let's take a look at part C. Part C here is negative 81 to the power 3 halves, okay? The exponent is only applying to the 81, not to the negative, okay? So this means I'm looking for the negative, my denominator, square root of 81. Once we find that number, we're going to raise it to the 3rd power, okay? So I know the square root of 81 is 9 to the 3rd power, so let me take my calculator, 9 to the power of 3, 729. And then we said, oh, look, we had this negative here, so let's not forget the negative there. Okay? And let's do a few more. So here's part D as in dog. Now notice this one, negative 27 in parentheses to the power 2/3. So remember what this means. We're going to take the cubic root of negative 27, and then we are going to square it. So if you remember earlier in the previous problem, we found the cubic root of negative 27 to be the number negative 3. Now we're going to square it. So remember what this means. This means negative 3 times negative 3. That's a positive 9. Okay? And then for E, 16 to the power negative 3/4. Let's see, E, 16 to the power negative 3/4. Okay, so remember, the fact that I have a negative exponent just means I'm going to make it positive by writing it as 1 over. Okay? And then don't worry about the 1. Just what does this mean? This means we're going to take the 4th root of 16, and then once we get our answer, we're going to raise it to the 3rd power. So remember, I'm grouping in terms of 4. When I think of 16, I think of 4 and 4. But I can break down each of these 4s into 2 and 2. So how many 2's do we have? We have 4 of them. Don't worry about the 1. I'm just writing it again, right? Excuse me. So now this is 1 over 2 to the 3rd Remember what 2 to the third means. It means write it out 3 times, right? 2 times 2 is 4, times 2 is 8. And I think there was one more there, yes. Negative 4 to the power 5 halves. Okay? Excuse me, sorry about that. Negative 4 to the power 5 halves. So this means I'm going to take the square root of negative 4 and raise it to the 5th. So one thing I wanted to mention here is that, here we go. It says a is any real number for which a to the power 1 over n is a real number. This is not going to be a real number. This is going to be that 2i, right? So here we would just say not a real number. Okay. All right. So let me scroll down a little bit more. And we just have a couple of rules for exponents. And again, we talked about some of this stuff before. When you multiply, you add the exponents. When you divide, you subtract the exponents. If we have a negative exponent, we just wrote it as 1 over. And then there's some power rules right here, right? So for this next part here, we're just going to kind of match which one's going to go where, okay? So let's do it this way. If I have 5 to the power negative 3, which is part A, right? Remember what this means. This means to write it as 1 over 5 to the third, which would be, excuse me, 1 over 125, okay? So this one here would match up with C, okay? Now this one here, there's a negative, 5 to the negative third. So remember, I'm going to worry about this part. That negative is just going to kind of come along with my problem. 5 to the third. So negative 1 over 125. So part B is going to match up there. Okay. Let's see. Now let's see if we can do part C. So I'm going to kind of scooch over here to the side where I have a little bit more room. C is negative 5 to the power negative 3. So negative 5 to the power negative 3. Okay. So this means it's going to be 1 over negative 5 to the third. So when I take negative 5 and I multiply it by itself 3 times, won't my answer be negative? Like this? And so part C is still going to match here, okay? So I want you to notice what the directions say. Choices may be used once, more than once, or not at all, okay? Now, look at the difference between part C and part D. What's the only difference? There's an extra negative. So if I put an extra negative here with this one here, wouldn't those two negatives cancel out? And so D would be matched with that one there. Okay. Alrighty. Let me back up here a little bit. And let's see. 4 to the power negative 2. Okay. This just means 1 over 4 squared. And 4 squared is 16. So part A is going to go right there. Negative here. Again, notice, look at the only difference between this part here and this part here. There was an extra negative. So wouldn't my answer here be negative 1 over 16? So that would be part D as in dog. Okay. Part C right here says, let's take negative 4 to the power negative 2. So I'm going to write it as 1 over negative 4 squared. Remember what this means. Negative 4 and another negative 4 is still a positive 1 over 16. So C is going to match up here. And again, the only difference between part C and part D, there was an extra negative. So if I put an extra negative, it would have to go there. So that one's going to match up there. All right. And so we have something similar here. I'm going to try to do the same thing. We're going to match up what we have in problems 9 and 10. see if we can match them up with our columns in 2. Okay. So let's take a look at this one here. 49 to the power, or 4 over 9, I'm sorry, to the power 3 halves. This means I'm taking the square root of 49, or 4 over 9. Sorry, I keep saying 49. And then I'm going to cube it. Okay. So first off, what's the square root of 4? Square root of 4 is 2. What's the square root of 9? The square root of 9 is 3. Now we're going to raise it to the third power. So 2 to the third means 2 times 2 times 2, which is 8. 3 to the third means 3 times 3 times 3, which is 27. So this one here will match up with that one right there, right? Okay. Now, let's take a look at part B. Part B has a negative exponent, right? So 4 over 9 to the power negative 3 halves. Okay, so remember what we would normally do? We would say, okay, let's write this as 1 over 4 over 9 to the positive 3 halves. Yeah, and we would do the same exact thing. So we would end up with 1 over, we already did this part earlier, and we came up with 8 over 27, right? So what does a fraction mean? Fraction means I'm dividing. So we're going to take 1, and we're going to divide it by 8 over 27. That's the same thing as saying 1 over 1 times the reciprocal, 27 over 8. So my answer is just 27 over 8, okay, which would be G. Okay. Now I want you to notice something here. When it was positive, we were able to find our answer real simple. Look, we can find our answer real simple when it's negative 2. Look at what the answer ended up being. Didn't we just flip this one right here? Yes, we did. So we'll continue to do that, okay? All right. Now, let's take a look at part C. Part C is a negative, and then in parentheses, 9 over 4 to the power 3 halves, okay? So this is going to be a negative square root of 9 over 4, and then I'm going to cube that, okay? So I know the square root of 9 is 3, and the square root of 4 is 2. I'm going to cube this, and I'm going to keep it negative. So 3 to the third is 27. 2 to the third is 8, so I should come up with a negative 27 over 8, which would be E, or F, I'm sorry, right there. Okay, so we've done that one too. So now let's do part D. It is negative 4/9, and the negatives on the outside, and then power negative 3 halves. Okay, so let me write it over here. Negative 4 over 9 to the power negative 3 over 2. Okay, so I'm just going to rewrite this as 1 over negative 4 over 9 to the power 3 over 2. So 1 over negative. Remember what this means. Square root of 4 over 9, and then cube it. So 1 over, let's see, square root of 4 is 2, square root of 9 is 3, to the third, and we're going to keep it negative. So this is 1 over, 2 to the third is 8, 27, we're going to keep it negative. So remember, we're just flipping this now, so this is going to be a negative 27 over 8. And a negative 27 over 8, which would again be part F, right? All right, and let's see, we can do just a couple more. That was this one right here is the one we just did. All right, so I'll tell you what, let's do a couple of these here. We don't have to do them all, but just a few. Again, I'm just trying to get you used to the idea of some of these with these exponents, okay? So let me see if I can do this first one here at the top. 8 over 27 to the power 2/3. Remember, this means cubic root of 8 over 27, and then we're going to square it. The cubic root of 8 is 2. The cubic root of 27 is 3. We're going to square it, and we end up with 4/9, right? So look at this one here. The next one, let's see. The next one here, if you notice, the only thing that's different is the exponent is negative. So remember what we said, when the exponent is negative, didn't we just take the reciprocal? So that one would have been 9/4, right? All right, so again, just some rules of exponents, okay, guys? And I think the next section, yeah, we're going to do is 4.2.